Hello, everyone. Hope you are all doing fine this Sunday. I hope you are having a lot of fun at the conference. Sadly, I couldn't make it myself in person this year yet again. I missed last year as well. Hopefully, if things are going as planned next year, I will be able to make it in person. However, at this time, another conference, another MicroOS talk, and there has been quite some MicroOS talks already. I would like to share my MicroOS journey. This goes back till the end of 2019 until today. So it gives quite some time for me to play and work with MicroOS, work on MicroOS, and to share some of the things that I run into. What most of you are running into, let it be MicroOS on the server side or MicroOS on the desktop side, which is now Ian. Sorry, Richard. But essentially, I would like to share all the different complications, what came with me switching from traditional systems, mutable systems, to immutable systems, and what were the challenges, what were the pains, considering that I'm very active on the Telegram side of things, I can see a lot of users are having pretty much the same problems or similar problems, and they really believe that MicroOS is this super restrictive system, and things can go south really quick. So let's get into it. Who am I? Right. My name is Attila Pinter. Some of you may know me as Adathor. I've been fairly active in the past few years in openSUSE. I'm mostly active on the Telegram side. I was helping out with documentation, still do some documentation. But mostly nowadays, unfortunately, I had to step away from the project to be able to focus on work. But hopefully this will be changing very soon. Right. Previously on how I did things, right? Essentially, we had a fleet of storage-focused server solutions, right? So these are very simple devices, hardware devices, physical servers, what we are talking about, running Leap and GlusterFS and a couple of additional things, custom tooling, that sorts of stuff. And we deploy these things to different customers or just rent it out to data centers and so on. These were all running Leap at the beginning. This goes back about 7 years or so. Most of the desktop side of things were running Tumbleweed. Very few workstations were running Leap. Let it be at home or at my own organization or at my own workstation. My workstation was always on Tumbleweed. Nothing else really worked. Always needed that that rolling state of things, and everything has to be up to date and modern, and I don't like to wait, really. I'm just impatient. Anyhow, I digress. The way we handle things like updates and configuration management, and where are we storing ABC packages, and what are the list of packages that we require to run a service, or run the storage solutions, or do any of these things, set up development environments. This was always done with Ansible and Git. So essentially it's like a GitOps type strategy, but nowadays they label as GitOps. But essentially this is how it was done, that we had a GitLab repository. We stored different configurations, different roles, collections, and then we use those, pull those in, and just deploy. There is no magic in that. This was almost all of them are RPM packages, very few Docker containers, because I really didn't like Docker containers. I still don't like Docker containers, but it was a very generic system, like most mutable systems, like most normal users have. I don't know if we as Linux users qualify as normal users. Anyhow, then the openSUSE Asia Summit happened in 2019, October, I believe, where Max had a very interesting presentation about Kubic. That really caught my attention. It was new, it was different, it was absolutely something that I had no idea about or how it works. I knew about the transactional and atomic systems at the time. I think even Leap, we had a few Leap servers which was running with transactional updates, not in production though, just for playing with. But I never really understood it fully, how it really works, and we're just like, okay, it's just a different package manager, what do we care, right? But during that conference, I was able to get a little more insights from Max, and he pointed out a couple of things about immutable systems about Kubic specifically. Now, keep in mind that Kubic was a Kubernetes distribution, which was really interesting for us, running quite a lot of services on top of other solutions. So this was really interesting, that we would be able to take a distribution which has all the tools in it that you would need to maintain a Kubernetes cluster on premise or in the cloud or wherever you can install it. So this whole idea was very attractive to us, of course. And then I was like, hey, hold on. So what any of these things mean? It was really fuzzy. I had a picture in my head, but here again, it's just a different package management. And it turned out that it wasn't. So we started to evaluate Kubic and MicroOS in 2020 because we haven't had anything else to do other than being locked up and just playing with the toys. So we started to play with it. Quite some time later, we started to come out with the first kind of impressions and reactions, and that we have to look deeper into the whole containerized ecosystem and how we would be able to fit this whole thing in to work for us. Essentially, what we want to do is do the same thing, but do it faster, do it better, and with less interruption. So we have more time for the fun and, just playing with things, trying out new technologies and such. So we really quickly came up with a list of missing things. The system was and still is super lean. It was very nice, very slim, incredibly quick to load it, and every time we press the button it just comes up and it's fast. But we were still missing a couple of things, like the firewall. I had a major freak out about that a while ago. I hope Richard doesn't remember that. But essentially Richard was the person who helped me through this whole reasoning of why we don't need a firewall. We ended up not using one, and until today we don't have one, because this is absolutely right from the project point of view, that if you have something installed and it needs to listen, you would open that port anyway. And if we are talking about cloud deployment, for example, we have a couple of Linodes running with MicroOS, which are all custom installations. We have firewall solutions directly from the cloud service provider. So why wouldn't we need this on the system? Well, the only reason we need it is to have not only the inbound logs, but also the outbound. But we kind of get around that using generic solutions like Prometheus. So we have an idea what comes and goes on the system still without installing a firewall. So that's one less package. Well, actually quite a few package. The other thing what really bugged us is how the system works. with transactional updates and the constant reboots what we had to do every day. It was really new that we really need to reboot this frequently. Now keep in mind that we do keep the systems up to date, and we do reboot them, but we are talking about once a week, not multiple times a day. Yeah, we will get back to that. Why? We had to define maintenance windows in the system for reboot managers, so all the nodes are not rebooting all at the same time. So these were all new to us. It was really, really new. But we really quickly started to love this self-maintaining idea. Because if we can get this right without writing kilometer-long playbooks to have the system maintain themselves with all the conditions, but instead we can just define the maintenance windows and the length of those on the system themselves, and we just get a feedback through the metric system, through the monitoring system, that helps us a lot. So we don't need to run all of these things. So the not how it works part, right? So the constant rebooting is what I mean here. So basically, okay, we installed everything as RPMs, right? So you know how it is. So you get used to something and you just want to keep using it, because if you don't have to learn a new tool because the old one still works, then you will stick with that. And oh boy, we were wrong, like really wrong. And it happened really quick, really fast, that we had to realize that this is not going to work. So all of a sudden, the systems that started out with a few hundred packages suddenly grew up to like 2,500 packages, and it was fat and slow, and updates were failing. It was a nightmare. But lessons learned. Just because you can doesn't mean that you should. And I used to say this quite a lot here and there, but matter of the fact that we didn't listen to this. We didn't listen to the developers. There were very few documentations available at the time, but the documentation said this explicitly, even at the time, that you shouldn't install packages into the snapshots that you don't need essentially for having the system to run. And at the time we had the toolbox method, right, for installing diagnostic tools, installing all the tools that we would need for the server, and we started to take massive advantage of that. Distrobox wasn't really a thing at the time. That's more on the desktop side. I still find Toolbox today a better option. On the server side, it's leaner and starts faster. What we didn't essentially install into the system, onto the whole systems, are tools such as VPN or mesh VPN solutions, what we are using for connecting all these infrastructure components together. This is Nebula, WireGuard, and such and such. Different kernel modules to make the 2.5 gig, 10 gig NICs running in the systems what we are deploying. So these things were all going to the host. So let transactional update handle that. But we need those to keep the systems running, right? So that there is no going around that, and that's perfectly fine. But everything else had to go into toolboxes. But I still don't like Docker. Luckily, there are a couple of alternatives, really good alternatives out there, like Podman, Nerd Control, and Cryo. Cryo is more on the container runtime for Kubernetes side of things, but it does a really good job, and they are really good at replacing Docker. And I really like the idea that Kubic was running with Cryo. It was a solid decision. and we really enjoyed working with it. We actually took advantage of Cryo on Kubic a number of times when we accidentally malconfigured our registry project. We are using Harbor, and we made a configuration error where we accidentally erased the images based on the age, not based on the size. So our quota system was all wrong. So essentially we ended up not having images in the registry, so some of the clusters were complaining and failing to do what they're supposed to do. But with Cryo we were able to extract the system from the system the images where it was still present and just push it back to the registry. So it saved us quite a lot of time. Podman is just fantastic to integrate with the system. In 4.5 recently it was getting a lot more updates. It just works really well to manage the different container services. And Nerve Control is just an immediate replacement for Docker. The point is that we never liked the idea of running every single container with root, at least not on the host side. So the daemon is still run by root. There's no going around that. Well, I guess you could, but what's the point if you have all these tools out of the box doing that for you? So this solved us a lot of problems, and it was much easier to get to work with containers. And then the config management, right? So as I mentioned, we be using Ansible and GitOps to manage all this stuff. And the thing is that Ansible still just works fine. We're just doing it differently. So I listed out a few collections here, what we are using, such as Community Kubernetes, or I believe Kubernetes core is not even valid anymore. But some Docker stuff is here, Podman. So we are essentially doing the same thing, but within containers, and it's still the same game, just easier. Same config management tool, same solutions, just faster. So by mid-2022, this was the go-to. So if we need to deploy a server that has to go with MicroOS, no questions about it. It took us over in a matter of months. So by the end of 2020, we were at the point that, okay, we need to have stuff where we can install this because it's so good and it saves us so much energy that we just started to migrate all these things from Leap and Tumbleweed onto MicroOS. This was involving some of the desktops, but the desktops were only coming around 2022. So by mid-2022, we had about 6 petabyte, closer to 7, of storage out in the wild with GlusterFS that we migrated away from Leap to MicroOS. We had about 23 servers. Entire load was moved into Kubic. So the 23 server has been freed up, and with about half of it, we were able to migrate everything into Kubic and Kubernetes. We were already doing some Kubernetes deployments, but mostly on cloud providers like Google Cloud, because it was easier. It was just a lot easier than maintaining and running it locally. Anyhow, most of the required services that we were running, such as databases, tunnels, reverse proxies, and so on, all of these things were moved from the traditional RPM installation into containers. This was providing us with a lot of sanity and just easier deployment and disaster recovery. So essentially, the way we kept all of this alive is just by CI/CD pipelines, taking the container files, executing what's in them, pushing it to a registry. From the registry, it comes down to the systems. And this was a daily cycle. So we never had issues with this, that how are we going to maintain the images, right? Because from that point onward, everything is just code, essentially. And the CI tools, the GitLab CI is great, Drone CI, or the actions, GitHub Actions are really good for taking care of this, and monoton, repetitive tasks, and having the ecosystem up to date all the time. So the DevOps is nice. So we managed to have all this running, and all the quirks worked out. It was just fantastic. But then Kubic just died. So Kubic has been sunset, I believe last year sometime. And we were still running a few clusters even after it was long gone. Yeah, this was one of those moments that, oh, okay, what are we going to do about this now? Because we were super comfortable with the tooling around Kubic, right? So it's not so much about the distribution, but the tooling around it, what the community was building around it. And it was just super easy to maintain your cluster or just build a cluster. So here again, disaster recovery. If anything happens, at this point we don't think twice. Then what should we do? What we do is just wipe and rebuild, and easy. It's really quick, and we are facing about 30 minutes of downtime at worst. So and not like we ever had to pull the trigger on that, but it was always it's always in the back of your head when you're working anywhere in your production environment. So this was important for us. So how are we moving forward? MicroOS didn't die. If I recall this correctly, MicroOS was a baby project from Kubic, and essentially it suppressed it. We still had combustion in the system, and K3s was very much running. So we were like, okay, let's look into this, how we would be able to get Rancher into MicroOS in an automated way, but it also has to maintain itself. So what we ended up doing is writing, this is just a snippet, but we ended up writing combustion files specifically for MicroOS for deploying K3s. So what this little script does essentially is just creates a K3s node. I believe this is from master. So it pulls from the upstream, right? It installs it, and just creates a unit file that maintains it and installs it. And to update the whole thing, it is simply just, wipe it, and with the next start, it will be there and it will be updated, so it will run just fine. So it was really easy for us to come up almost overnight with a solution that, okay, what are we going to do? We already tested Rancher, we already knew what Rancher is, already knew how Rancher works. We just had to come up with a way that essentially MicroOS on the first boot is able to set up a whole cluster for us. Currently, even at home, I have a 6-node K3s cluster running with this exact solution. So this solved a lot of things for us. But then you could ask that, okay, all of your systems worked with Leap and Tumbleweed and all these mutable systems, so why? why would you go through all this pain, all this migration? It's simple, really. We had we had systems and services that are self-maintained. They update themselves. They don't really have downtimes. We have all the tooling around it, right? So if the system updates themselves in the designated maintenance window, I know that they will always come back. So Health Checker was there fairly early on, and it still is really easy to configure and write your own Health Checker scripts for the system to check if your services are actually running. And if it's not running, it will reboot it, restores the previous snapshot, and the next time it will try the same thing again, and it will do it until at some point it will work. And if it doesn't work, we can still monitor these situations, and we can just go into the system and fix if something is really broken. We have all the tools to get the systems to reach self-maintenance with transactional update, Podman auto update, Ansible with drone CI and GitHub Actions, Argo CD and GitOps for Rancher. If you don't know Argo CD, look into it, especially if you're into Kubernetes, but you probably heard about it already. It's a really great tool for keeping the systems constantly up to date. We were essentially able to unify all the environments across the board, and just have more time for innovation and working on stuff that we actually like to do, not just constantly following all these CV lists and oh my god, when are we going to update? Oh my god, we need to notify the customer. In this case, the customers knows exactly that whenever the systems are updating, they will come back in about half a minute or a minute with all the services running. And if they don't come back, which actually never happened yet, then they know that there is probably something wrong, and they know who to call. So it gives you that sanity check, basically, that you don't need to worry about these things anymore. That, oh, I need to track this or I need to track that. We still do tracking, especially on vulnerabilities, but it's not taking up that much time of our data. Oh, okay, there is a vulnerability. Has this been fixed? Yeah, it has been fixed. The update is already in place. So, yeah, it saves a lot of time and effort. We haven't had any major incidents or outages in the past 2 years, which is kind of telling something. I think the longest downtime we had once was about 10 minutes, 15 minutes, because the server just got a bigger load, but it had nothing to do with MicroOS. We essentially reached the state where we have centralized maintenance. Long story short, a computer's job is best done by a computer. So let the computer do it. And with that, look into containerization. Don't be scared of containers. Try out MyMicroOS Desktop Aeon. Try out Aeon, give it a go. It's awesome. And if you have any questions, please feel free to drop me an email. Thank you, and have a lot of fun.